Hello, everyone. Can you see me? Yeah. Hopefully you guys can see me. Okay. Good afternoon, everyone. I'm Jianfeng Chen, together with my colleague Kata from Facebook. Today we will talk about the integrating a custom language in Facebook, GraphQL as a case study. So before we start, Kata, do you want to say hi?
Yes, so today, just as a context, today we will present advanced topics on GraphQL grammar integration. And if you are new to Android Studio plugin development, check this introductory presentation from the DroidCon London last year. It also includes examples on open source Android UI library Litho. And speaking about today's presentation, by the end of our talk, you will know what is GraphQL and its advantages for scalable data fetching, how to add rich support in Android Studio for any custom syntax, and how to scale that support outside Android Studio with the help of language server. We will include useful links in the end, and if you have any questions during the talk, please ask them in the end, and we will be happy to answer them. So we are presenting these topics today to you. My team focuses on efficient tooling for mobile development. My name is Kata Zavorotchenko, and I'm a software engineer in a London office, and my colleague.
Okay, yeah, thanks, Kata. I'm Jianfeng Chen from Facebook. I am a research scientist. Our team is working on providing the mobile GraphQL infrastructures, or specifically the building infrastructures we will talk about later, to our Android developers and iOS developers in Facebook. I am located in New York office, actually. Yeah. So let's start from our today's topic. First of all, I would like to talk about the GraphQL, this language for the Android developers in Facebook. The GraphQL language was originally developed by Facebook in 2012, and we moved that to a non-profit GraphQL Foundation in 2018. So everyone can use that right now. As you can see in the chart below, we have three major steps to use the GraphQL. First of all, you need to describe the data as a schema. I will have more details later about this. And then the mobile developers can write the query for the data to request for what they want. And finally, the server can get predictable results as they queried. One common question about the GraphQL is what's the difference between the GraphQL and the REST? So they have some similarities, first of all. Both of them are reading and writing data, and both can return the JSON data in request. But in difference, inside the REST, the shape and the size of the return is determined by the server. But in GraphQL, the schema defines what resources are available, and the client fetches for what it needs on it, aka the return structure is predictable. So let's see this more detail. In here, we have two sides. On the left-hand side is the schema we should define in the server. And on the right-hand side is a query we need to, the developers want to fetch or specify what they want to get from the server. So in this example, in the schema, we have a query, the user query. The user query accepts a user ID, and then the return type is a user. For the user type, they have four fields there: ID, name, friends, profile, picture. And specifically, the profile picture is an image, which contains the URI, the width, height there. This is just an example, not the data inside Facebook. This is just an example for demonstrations. So after people define the schema in the server side, on the right-hand side, the mobile developers write some query. For example, right here, they have a query which is asking for a user by some IDs. So as the schema defined, this should return the user type. And in this query, people query for four things: ID, three things: ID, name, profile picture. And for the profile picture, they don't need everything. They just need the URI. So we don't have the text right here because everything, the type is defined in the schema. And people just need to define the field they want to get in the query. So in this way, in this example, people do not need to get everything from some type. So this is what we mean. The result of the GraphQL is predictable. Yeah. So in Facebook's practice, for the mobile developers, first of all, they need to write a GraphQL query. And then with this query, our building infrastructures, which we'll introduce later, convert this query into the Java code. In this Java code, we provide many useful APIs for them. For example, how to initialize a query, how to set up some arguments there, what's the return type, and then how can they load the data we fetch from the server. So with this coding in Java, people can use that in any business transactions. For example, in this example, they put this inside a method called onActivityCreated. So and so on. This is just an example. So the main part right here is about the code generation, which is provided by our infrastructure team. So to convert the Java GraphQL code into the Java, we have a couple steps. First of all, we need to read the GraphQL text from the file, and then we convert that to the AST. The AST means abstract syntactic tree. So on the left-hand side here is a query. On the right-hand side, we load these just like the compiler as a language and construct the abstract syntax tree. For example, we have a document for it as a higher level layer, and then we have a query, the name, the selection set. In the selection set, we have two fields, last name and the settings, etc. So something like that. We create a syntax, abstract syntax tree. So in this abstract syntax tree, it is completely transformed from the GraphQL query text. And then for the last step, we convert the AST into the IR. The IR means intermediate representation. The difference between AST and IR is that the IR also loads the info from the schema. So in this AST, we do not load the type for each node, but in IR, since we have some information from the schema in the server, in IR, we know the schema types for each field, for each node, etc. With this information, we are ready to cogent with some type of Java templates, which is pretty simple. And then we write out the Java code for people to use. This is the whole fundamental essential steps we are doing the code generation in Facebook. Previously, we are using the command line interface to do this coding for the user. So for example, when people edit some GraphQL text, they are running some kind of commands or script to get the coding. In this chart, we show that our infrastructure discover an error. For example, right here, the field does not exist in the server-defined schema. So we return the error for that. It's pretty good, but the problems right here is that people need to run a script to get the coding, and the script first validates the GraphQL and then generate APIs and implement it. So they have some kind of delayed feedback. They do not know this field does not exist when they are doing the typing in the IDE. So and as a last one, the developers may forget to run the script, and terminal is disconnected from the editor. For example, we mentioned that, okay, so in this file, in this lab, you have some errors, but the developer needs to go back to the IDE, open this file, and locate the error by themselves. Given these limitations, from last year, we are working on convert or transfer this command line tool to a plugin in Android Studio. So with the Android Studio plugin or native supporting as a GraphQL languages, we can provide instant validations, and people are able to track tags of fields and fragments, etc. They can also do the auto completion, and everything is left to the editor and our mouse cursor. Everything is also integrated with our Facebook internal infrastructures or also other custom activities or other custom features extendable. Yeah, so let's have a look at how the Android Studio integration works. So I would like to switch to Kata. Yeah. Kata, you are mute. You are mute, Kata. Kata, you are okay.
Yes, thank you. I knew something happened on my side. Okay. Speaking about the Android Studio integration, unsurprisingly, research shows that product developers spend 80% of their time in the IDE on coding. And during this section, I will be talking about Android Studio specifically, which is based on the JetBrains IntelliJ. All Android Studio integrations is realized with the plugin architecture. You can find all plugins in the IntelliJ installation directory, and plugins are just archives, Java archives or zip archives. And if you look into the content of those archives, it contains source files written in the JVM language like Java or Kotlin, and metadata such as configuration files, icons. Plugin.xml under metadata directory is similar to Android manifest file. It tells Android Studio which extension points are implemented by the plugin to trigger. So Jianfeng just showed us an example of this powerful data fetching library, GraphQL, but custom language does not have support out of the box in the Android Studio. This is what developer will see by default, just a text as in Notepad. And our end goal is to have a rich support that will look like this to the right. So let's investigate which features does it mean to have a rich support. The first basic one is the file type recognition. Here is example of a typo actually. And if you spot the typo, it's a bonus points to you. So here we have a graphical instead of the GraphQL extension. And it is hard to notice because incorrect icon for the incorrect extension look exactly the same as the correct one. But if we add a custom GraphQL icon, it is visible at a glance if the file of expected type or not. So expected type or not. The next one is lexical analysis and navigation, so that Android Studio can navigate, for example, from the fragment usage as here to the fragment definition in some other file just with a click. And the last but not least one is a syntax highlight. It allows, in this example, to recognize parameter maximum posts and field groups tab just with a glance within a second, just based on the coloring. Okay, so let's start looking into the implementation. File type is realized via extension points in those plugin.xml files that I just mentioned a minute earlier. As you see from this example, it needs implementing both a language file type and language interface. It sounds a bit scary, for me at least at the beginning, but fear not, implementation is straightforward. So we return basic information like GraphQL name, file extension like .graphql, and icon that we want to represent this file type. And that's it. A few lines of code and we have custom file type recognition. Yeah, First milestone to celebrate. Oh, the next step is far more harder and arguably the hardest in the implementation of the custom language support. This is lexical analysis. This is implemented via parser definition extension point, which requires implementing lexer and parser. So we will dig into them a bit deeper right now. And now it's a good time to recall those university lessons on compilers. So let's start. What is a lexer? Lexer, lexical analysis, also known as tokenization, scanning. It is a split of a given text into tokens in a non-overlapping manner. So there is no strict rules. This tokenization should make sense for your specific language. As in my example here, we have type, keyword, we have white space, we have image, names, tokens, again, white space, and some punctuation like open braces, close braces. In compilers, as you know, lexical analysis also includes reading the file input and storing tokens output. Luckily, in Android Studio, this processing is handled by the Android Studio infra. So what we need to do is to only define tokens. We define them in file with extension .flex. So here I will be now showing the snippets from open sourced plugin, which is similar to what we did for our internal GraphQL integration. The simplest way to define a token is to just have a hard-coded text. So here we are returning the constant like brace. And this name is custom. We can choose whichever name makes sense for our grammar. So if there is more like less defined strings, like for example, we want to match for naming, we want to match any alphanumerical elements, we can use regular expressions. If the pattern is overlapping with something, like you can imagine that we want to have a type keyword and it will be matched by this regular expression as well, then precedence of definitions matters. So if we put the type definition above name definition, when the lexer matches the text against the type, it will stop, return, and would not go and match against next patterns. Another interesting point is that lexer should also suggest full coverage for all symbols. So if our custom grammar does not support some symbols, we need to mention it explicitly. For example, we return byte character token in this example. If we did not do that, it will be throwing an analysis error. Okay, finished with the lexer, now to the parser. Parser defines high-level structures, which takes lexer output tokens as an input. All results returned by parser usually equal or larger than those lexer tokens. So let's take an example. We want to define a variable definition. Again, no strict rules. We split it into parts that make sense for our grammar. So here we could define it, for example, as a variable, semicolon, type name. Could we split it further? Yes, like we can have more levels of in our tree. The main rule is that these tokens returned by the parser should be equal or larger than the lexer tokens. So there should not be the case when we are showing the part of the lexer token. Okay, we know what is the input, what output looks like. The name for the output is the PSI elements, program structure interface. And what is PSI tree is just a realization of the abstract syntax tree that Jianfeng mentioned earlier in the Android Studio environment. This is a screenshot how Android Studio parses each file into the PSI tree. What we can do, we can create all those PSI classes manually, but Android Studio allows to generate classes based on the BNF config file. Token definitions in this .bnf file is similar to what we saw previously for the .flex file. So as you can see, we can use hard-coded strings or regular expressions. Note that we use equals sign here, and this is to show the is a relationship. So in this example, brace is a hard-coded string. If we want to show has a relationship, so for example, variable has a variable name, we use this double semicolon. We also can introduce in these tokens new logic. So there is an implement keyword that tells Android Studio during this PSI generation to make this class implements named element interface. Android Studio relies on named elements for features like renaming, for example. We might also want to add custom logic to our generated classes, and the word mix in tells Android Studio to make, in this example, identifier class extend reference element class. Let's look into this GraphQL reference element class and see what we have brought with it. So the naming here is again custom. We name it GraphQL reference because we wanted to implement getReference method. And this method is a standard method in a PSI element class. Android Studio relies on this getReference method to implement completion and navigation. So in this GraphQL reference class, if we look into it, there are two main methods. One is resolve, and it's responsible for navigation from the usage to the definition. And another is getVariance. It's responsible for completion suggestions. This is a good place to add our custom logic. We don't need to do any filtering, so Android Studio will filter results as needed based on the user input. As you might imagine, search in the big repository could take a long time. And for your information, these methods, they could be triggered like dozens of times within a second. So it's important to have efficient search mechanism and efficient caching mechanism in place. Caching is outside of our today's talk scope, but JetBrains documentation contains useful examples if you're interested. So, okay, we implemented this parser, and yeah, that is another milestone to celebrate, I would say. So now all GraphQL files are parsed into this PSI tree representation for our custom grammar, and we also have navigation and completion. Have we finished? Just looking into this black text, you might guess what is next. So the last but not least feature is the syntax highlight. And because Android Studio does not do any automatic guessing how to color our parsed elements. There are two levels of syntax highlight. First, the basic one is implemented as factory extension point in those plugin.xml file, and it takes Lexer tokens as input. So text attributes is the class here to define text characteristics like color, boldness, cursive. We can create custom color, or as in this example, reuse some existing one, like default color for keywords. Main method to implement here is the get token highlights. It accepts the Lexer tokens. This method synchronously, as you may see, return results, and it's also called on a very critical path when developer opens a new file. So logic here should be as fast as possible, and that's why we used hash-based comparison with equal method. But yeah, like said, map-based solutions will also give constant time mapping, and it's good to use in these classes. As you guess, such approach that I just described, it allows us to highlight unique patterns. But what if we want to color name token? And for the name token, we have like type name, variable name, parameter name. We could not distinguish between them just by the Lexer token. For that, we would need the parser output. Annotator is another extension point which allows us to do that. It uses the same text attribute concept to coloring the elements, but main method here is annotate, which does not return any results, and we need to populate this provided parameter holder ourselves instead. To retrieve all elements in a PSI tree of a given element, we use the visitor pattern. And this GraphQL visitor is something that is generated also based on those BNF file that I mentioned a few slides back. This visitor has all methods for custom PSI elements. So in this example, it will have the method to override visit fragment definition. Holder method, so how we populate this holder, calling its methods, and it will return an annotation object which may be formatted with text attributes. This annotation object also allows to attach actions to it. I will not stop on annotation actions for now. JetBrains documentation contains more examples on this topic if you're interested. So, okay, at this point, we have syntax highlight and navigation. That was quite a lot of work to do. What else Android Studio suggests to empower developers when using our custom language? So additional features implemented mostly via extension points as well. And yeah, like literally everything that you use in the Android Studio is a custom support. Like Android Studio does not do any guesses based on the lexical analysis. For example, the commenter, it's so seamless that it's easy to not even notice it, but it's there, but it's a custom implementation. Folding, useful to collapse big blocks of information and improve readability. Android Studio does not have any guesses about braces as well. So for brace bar matching, there is additional config file. So what we have seen so far, already what I described, it was everything about the editor experience, like editing code, coloring code, code completion. But Android Studio also allows support views outside editor. For example, file structure view presents human-readable description of the open file, and it supports navigation between elements in it on click. Woohoo! Congratulations! We just finished fundamental support for the custom language in Android Studio. As no one says, there is nothing to do in this project anymore. So you might have noticed that features I listed are heavily rooted with the Android Studio internal PSI infrastructure, but GraphQL is a cross-platform tool, and it is used by developers not only in the Android Studio, but for example, in the VS Code. How would we scale this support to other IDEs and avoid duplicating the work? In next section, Jianfeng will tell us about language server approach and how we approach the scalability problem.
Yeah, great. Thanks, Kata. So in this session, let me talk about the GraphQL IDE language server, which is available for multiple IDEs and integrate with more custom features and Facebook infrastructures, and how we do that. How do we do that? So first of all, let me introduce a term, the RSP. Probably some of you may not know this. The RSP is for Language Server Protocol. It is an open JSON RFC remote process control-based protocol. It was originally developed by Facebook, developed for Microsoft Visual Code, but now it's an open standard. In this chart, you can see we have two sides. First is the developer tool, the host, for example, the VS Code or the Android Studio we are using for Android developing. And the other side is the language servers. So the developer host sent some JSON language server protocol JSON, for example, some request or some event to the language server, such as people move a cursor to a token, the host will send on Harvard for some token at char X of file Y, something like this, to the language server. The language server can do some calculations or operations and return back the response for this. For example, the return will be we need to have some, we will have some warnings for the token at X of line Y, And then, so with this part, the IDE, when IDE accepts this response, they can automatically render this information and provide that to the users. The benefit for this framework is that we can reuse many things. For example, right here, we have the AS, VS Code, and XCode 3 editors. Each of them has a lightweight LSP client. In Android Studio, we have many open source LSP clients. In VS Code, they have native LSP client supporting. So the client side is lightweight, and then the server side is what we need to focus on, and the server side is able to support for multiple IDEs. And what's more, the server can also connect to many existing GraphQL infrastructures we have invested in Facebook for many years. So in this whole process, we just need to create a layer of client side and the LSP server to get all kinds of extensions for LSP for the language plugin for multiple IDEs. This is simple to use, and we can reuse our existing CLI info or scripts. Also, we are providing unified preferences across various platforms like Android Studio or the VS Code. And finally, some advanced features we can also move to the LSP. For example, people do not need to run the script to do the coding. In the future, we are planning to move the coding logic to the LSP, and then people can get the generated code immediately when they do some editing. So to use the LSP in AES, it is pretty simple. First of all, you in the method of plugin.xml, you can assert this into the activity on starting activities. Just register that in the XML, and then you should move your focus to the server side. In the LSP server, it is a binary that listening to the LSP client, and it is just a binary. Since it is just a binary, you can develop it by any programming language. In Facebook, we use the ROS because ROS is famous for its safety and performance. So in this example, in this API, we show the hovering request. For example, the LSP client can listen to the client and get some hover parameters. What you should return is the result of the hover, which contains the warnings or other kinds of activities you want to run. You want the IDE to render, and at what place they should render, and what message you want to render in the IDEs. As long as we define this and return back with the JSON format, the LSP client is able to fetch this JSON and render that in the IDE, for example, the Android Studio, and provide that to the developers. So this is the, if you have questions about this talk or about GraphQL language, here's some useful links you can check out. Yeah, that's the end of our talk. We are happy to answer any questions or any comment or feedbacks. Yeah. Any questions?
Yep. If there are no questions, we can get back a few minutes.
Sure. All right. Thanks, everyone. Have a good one.